function is not cannot be solved by factorization. Let's take a very quick example of that. Now let's say we look at the same function, but just change one thing. Let's say even if I change this to 1. What happens here? Then everything vanishes. This becomes 21, this becomes 21, this becomes 21, and what happens here? This would become 24 times 21. 24 times 21. It would be, I think, 484, but let's do it. And 4, 0. So it should be greater. Why is it becoming less? So yeah. So this is right. This is right. 484. But when I add that, it is going to be 533. Now the square root of 533 is greater than, so this 533, so observe that 533 is greater than 529 but less than 576. 529 is a square of 23, this is a square of 24, so this has to be a square of something that is between 23 and 24, and hence it is not a perfect square. Well, we can see that it is ending at 3. No number when squared gives you 3. So immediately we know that it is not a perfect square. So this one cannot be solved by, this can't be solved by factorization. Okay, when it is 21. If we apply the same formula, like to apply the same technique, what happens? Same technique. Let's change this to 21. Now the product will be 126. And what are the factors of 126? Of course, these are the factors. With the 2, it is going to be 63. With the 3, it is going to be 42. It is not divisible by 4. It is not divisible by 5. It is divisible by 6. So when we divide by 6, we get 21. It is divisible by, so it must be divisible by 7 also. So when I divide by 7, I should get 1. So negative, positive. Let me change that. Positive 1, and then 56, 18. Okay, and I could continue, go on, like it should have 9 also in it, because when you add them up, 7 to 9, it is divisible by 9 also, and I could find it should be 1 and 14. Well, I could continue on, and you'll see that they would never add up to give you 7. Doesn't matter whatever factors you take, because now what will happen? Now they will start going back. Here you will have 14, 9, and they would never add up to give you positive 7. Because if you do this, you'll get 125. You do this, you'll get 61. You do this, you'll get a negative positive 39. If you do this, you'll get positive negative 15. When you do this, positive negative 11. When you do this, you'll get positive negative 5. But it never becomes 7. So this is non-factorable. We verified that with our discrimination. Discriminant was 533, which was not a perfect square, which already told us that this cannot be solved by factorization. Once it cannot be solved by factorization, we tried to still employ our technique, multiplied A with C. We found its factors. None of the factors would add up to give you positive 7. We could still graph and find the roots by using our quadratic formula or completing the square method, but those will not be. Just to see that quickly, let me just show you on Desmos. I just changed one thing, which is change this to 21, and you will see now where does it cut. These are not rational roots, these are irrational roots. They are approximating them with these decimal numbers, but they are definitely irrational roots. Any questions? If none, Thank you.